Math 7. Today we are going to learn like what you see over here. And by the way, sorry about the wrong title, Unit 9, Probability. Today's lesson is known as Probabilities of Simple Independent Events. So we are going to combine what we learned at the beginning of this unit, which is probability calculation and sample space together. There is a possibility that this lesson can be broken into two different parts. One that go through grade 7 method and another one, which I'm going to do a little spoiler alert. There is an easier way that you can use, and I believe that overlap a little bit in Math 8, but it's as long as it clicks to you guys, I'm going to use it. In this lesson, like I mentioned, two previous lessons together. Without further ado, let's go through some example. There you go. First question says, I'm going to read everything first. A school gym has 3 doors on the stage and 2 back doors. During a school play, each character enters through one of the 5 doors. The next character to enter can be either a boy or a girl. So, as you may notice, we're talking about two different events. One event is about doors. Second event, we're talking about biological gender, a boy or a girl. So the first probability talk about these 5 possibility, and we can use tree diagram or the table. Oh, never mind. This question asks you to draw a tree diagram. So we're going to do tree diagram, which is 5 branches a start. And then next, we're going to find out whether it will be, let's say, back left boy, back left girl, like 2 possibility for every single scenario. So without further ado, let's start with our A portion. Start from the center. I'm going to create 5 possibility. So let's see. 3 doors on the stage. Why don't I start from there? I'm going to say left stage at the first. LS. Center or central stage. I'm going to put CS. The next, let's see. I'm going to put right stage, which is RS, left back, LB, and due to the space issue, right back, RB. Something like that. Oh, I just found that. You guys cannot see the whole thing that I wrote. This is the whole setup. I start with a left stage, central stage, right stage, left back, and right back. Sorry about the space issue. I can only show a few segments every time. And then, as you may notice, I have a quite a lot of things to write down. Boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, something like that. So we have all of those sample space, and we can summarize these. I'm gonna put that on the side so that it's easier for everybody to read. First possibility is left stage boy, left stage girl. The next one, central stage boy, central stage girl, right stage boy, right stage girl, And I'm gonna continue writing on the side, comma, left back boy, right back boy, order doesn't matter, left back girl, right back girl. So total possibility, first of all, we have total 10 outcomes available. So in this situation, we know that out of these, there must be some condition that satisfy our question B, which is the question is asking what will be the possibility for boy who enters central stage. So is there any central stage boy possibility? And we need to answer as a fraction and as a percentage. Right now, we could locate boy with the central stage, which is our desired outcome. And we only have that as one possibility. So I have 1. Total out of 10. So when it comes to our B calculation, as soon as we find out the whole sample space, it is really easy to figure out our one desirable outcome. Just like that. We just need to locate. And then just remember, top number should be our desired event. Out of denominator is always total outcome. So using that 1 over 10, that's a fancy way of saying 0.1. When you try to do percentage, then you need to multiply by 100, and that is equivalent as 10%. So 1 over 10 is equivalent as 10%. That's how you answer this problem. So it is not something that is different. We just combine, like what I mentioned, the first components and second components together. Next one, create a tree diagram to show all the possible outcome when a coin is flipped. So I'm going to highlight event by event. Coin flipping is one event, and a spinner with 5 equal sign, which is my second event, that says run, skip, jump, twirl, and twist is those 5 sections. What is the probability a student would flip a coin and spin the spinner to land on jump? So we are going to go through this traditional style. That's our first part today. There is no shortcut. And to be fair, there's no shortcut in grade 7 method unless you go to grade 8 and then learn the probability formula and then statistic, a little bit of them. So first thing first, coin that is flipped. Let's actually use table this time. Even though it says tree diagram, we did tree diagram a lot. Why don't we use table for people who prefer table? Then here's what I'm going to do. Decide whether vertical or horizontal column, which one of the event. I'm going to use coin, head, tail, like that. And spinner have a 5 sections, so run, which I'm going to use the word R. Skip, which I'm going to use S. Jump for J. Twirl, which is TW I'm going to put. And twist, I'm going to put T. It's very similar, so just have that in your mind. I don't know whether I can show the whole thing in a one screen or not. Let's see. First combination, head and run, tail and run, head, skip, tail, skip, head, jump, tail, jump, head, twirl, tail, twirl, holy, head, twist, tail, twist. So if I focus on the inner component of the table, we can conclude that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, it's same as previous one. 10 outcomes is what we have as a total 10 outcomes. And we can find out our probability. So, probability, so first part done. This is like part A. Part B, we are trying to find the flip a coin that has head and spin the spinner to land on jump. So H and J. Do we have any of those possibility? Yes, we do. Head and jump. So in that situation, we only have that outcome 1 over 10, same as before, which is 0.1. And if you multiply by 100%, that is also 10% possibility. I hope the next example doesn't go with 10 outcomes. Let's see how it goes. Marble. Okay, now I see. A marble is randomly selected from a bag containing 1 blue, 1 red, 1 green. And then 4-sided die is rolled. So as you may notice, the highlighter is dying. I'm going to pick something else. This should work. Let's see. The question provides a marble, which is event number 1, and 4-sided die, which is event number 2. So we have our first event and second event happening, and let's use table again because we have been using, and the question says use a table anyway. Without further ado, why don't we create? So marble has 3 possibility and die has 4 possibility. It doesn't matter how you choose to do, but I like to do marble on vertical because I just feel like it. Doesn't really matter. Die, I can put it on the horizontal. So 1, 2, 3, 4. So I know that each of them can have equal 4 sides. And marble, what color do we have? Blue, I'm going to use B, red, and green marble. So there you go. G, R, and B. And our last part is create all of those possibilities to figure out our sample space, which goes into this given space over here, which is quite straightforward as long as you be consistent. The first one is blue and, blue and 1, blue 2, sound like Bluetooth, blue 3, blue 4, red 1, red 2, red 3, red 4, green 1, green 2, green 3, green 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibility now. So it's a good idea. Total 12 outcomes to have it in your mind because that becomes your denominator. And let's go through each of those steps. B, what is the probability of choosing any color, any color, and rolling any number but 3? So that means I can pick like 1, 2, and 4. Wow, already it's a big part of the question right now. We need to deal with complex situation, probability more than one condition. So first thing first, what kind of condition that fits for B situation? I'm going to use red color to identify. You don't have to use a color code, but I'm going to use it. So any color means, well, blue, red, green. It can be any of the row. Also, 1 column, 2 column, 4 column work. 3, we exclude this possibility because those are not a desirable outcome. So if I answer B using properly now, I can say P color, comma, you need to put condition. In fact, any color is okay. Any color, comma, 1, 2, or 4. Yes, and we can count what I checked. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 12 outcome. Note the fact that this is not my final answer because I have to simplify everything using a common divisible number, which in this case, everything can be divided by 3. 3 over 4. And 3 over 4, you guys know that this is a common fraction. It's, imagine you have 3 quarters and how much money that you have. That's 75 cents. So 0.75, which is 75%. So to satisfy these conditions, having any color, 1, 2, or 4, it's actually 75% of a chance that you will get it correctly using random event, and that's how you do. So probability go a little bit more tricky. See, what is probability of blue or green? I'm going to use my blue color. Blue or green, and have a number greater than 1. So 2, 3, 4 possibility. This time, let me put a little circle. So first thing first, blue or green, that means B or green situation. We are excluding this red over here. And what else does it satisfy? 1 is not included. It's greater than 1. So 1, 2, so B2, G2, B3, G3, B4, G4. So that's 1, 2, 3, 4, 5, 6 probability. So that means probability of blue or green, comma, and having any number greater than 1 is 2, 3, or 4 possibility. By the way, I forgot the word and in between, so just have that in your mind. Turn out to be 6 over 12, which is not a simplified fraction, so we gotta divide it by common number, which is 6. 1 over 2 is what we have, and this is 0.50, which is 50%. So you have 50-50 chance of taking blue or green, and if the condition for that is 2, 3, or 4 for the dice. What about P, black, and 1? First thing first, we call it impossible event. Because you have 0 possibility, 0% probability. Why? We only have blue, red, and green, but we don't have black color, so that's why. Easy as that. E. What is the probability of having a red or green or blue and selected and die number display at 4? So probability, we have, basically we can say any color, and you have a probability of 4. So this part is easy because now I'm going to use a green color for this guy. Any color means blue, green, red. Any of these colors, okay? And you need to have located your possibility for 4. So technically, these 3 possibilities are the only one. And you can summarize this by doing, this is 3 over 4. It's already simplified, which is 0.75, which is 70. It's 3 over 12. Which actually needs to be divided by 3. Sorry, I thought the probability is quite high, which is 1 over 4. That's more like it, which is 0.25 or 25% of a chance. I believe today this is a good point of pressing a pause button, even though I have one more question up there, but I think that's a good question that I can go as a review question. The homework problem will be given right after this, so please don't close the video.